live broadcast. My name is Kaleem Akbar. I'm the endorsed author of Cambridge IGCSE Physics Explained and Edexcel International GCSE Physics Simplified. What I'm here to do today is do my first live broadcast, probably make a couple of mistakes, but let me give you a little insight into the purpose of this channel. What I intend to do once I get into the groove is to do exam questions on a daily basis from different parts of the GCSE, IGCSE syllabus, whether it's AQA, Edexcel, Cambridge, it doesn't matter. All right. There is a lot of overlap between these syllabuses. I'll be making sure that you know when there are differences and when there's commonalities. Once I start creating folders, you'll get an idea of where everything needs to be. So for today, what I've got in front of me here is an exam question from the Cambridge syllabus. It was May, June 2014, paper 3, variant 2, and it's all about electrical circuits. And what I want to do for my first broadcast is basically just go through this question to give me a feel for how this all works and to check that everything is okay and to hopefully add some value to you. So, guys, it says here figure 8.1 shows 3 cells, each with EMF 1.5 volts, connected in series. Now, what do they mean by connected in series? Well, basically, what they mean is connected within the same line here, right next to each other. All right, so you got 3 of them. You get 1.5 volts, 1.5 volts, 1.5 volts. All right. And the first question basically asks, well, what is the combined EMF of all 3 of these cells? Well, I hope that's kind of quite obvious. If you've got 3 cells that are 1.5 volts each and they're in series with one another, then the total voltage is going to be 4.5 volts. Okay, so 3 times 1.5 is going to give you 4.5 volts. Then it says calculate the combined resistance of the 3 resistors shown in figure 8.1. So if we go back up to figure 8.1, what do we have going on here? We've got 2 resistors in series, the 4 ohm and the 1 ohm, and both of them are in parallel with the 1 ohm resistor down the bottom. So if I show you here, we've got 4, we've got 1 in series, so that's 5, and then we've got it in parallel with the 1 ohm resistor. So how should you calculate this? Well, students generally understand there are only 2 ways. And the formulas that most students are familiar with in series, RT equals R1 plus R2. And they're also familiar with normally 1 over RT equals 1 over R1 plus 1 over R2. The one that I tend to use at this level, guys, because, in the IGCSE syllabus, you're only ever going to calculate 2 resistors at any one time. So I tend to use RT equals R1 R2 over R1 plus R2. So those are the 2 I'm going to use. I'm going to call this number 1. I'm going to call this number 2. Now, how will I tackle this? Well, I've only got 2 choices here. Do I go parallel first, then series? Or do I go series first, then parallel? Well, if we come up to the circuit again, if I was to try to do 4 in parallel with, let me just point it out here. If I was to try 4 in parallel with 1 and then 1 in parallel with 1, what I'd like you to notice, forget the physics for a second, from a logical point of view, I'm using the top 2 resistors once, and I'm going to use the bottom one twice. Well, that doesn't make sense. Okay, putting the physics aside, there will be other lessons where instead of doing exam questions, I'll explain theory. But right now, I'm trying to give you a kind of short logical way of looking at this and going, okay, how do I not make a mistake? Because that is the mistake in the exam, where students might use the wrong formula first. They'll do in parallel, then in series. So I hope that makes sense, that you cannot do in parallel 4 in parallel with the one underneath and the 1 in parallel with the one underneath. because you're using the one underneath 2 times. It doesn't make sense. So what we do is we use the series formula first. What we're basically going to do is add the 4 and the 1 to get an effective resistance of 5. Well, why does that work? It works because, you know, you're only going to use those 2 resistors one time. So if I come down here and I do, sorry, let me just come back up. So I'm going to do the series part first, where I'm going to do RT equals R1 plus R2, which is 4 plus 1, which equals 5 ohms. All right. Then what I'm going to do is I'm then going to do that in parallel with the 1 ohm resistor. Notice I'm only going to use each resistor once. So RT equals R1 R2 over R1 plus R2. So this time I've got 5 times 1 over 5 plus 1. So basically I've got 5 divided by 6, which gives me 0.83 ohms. So guys, I hope that makes sense. That's the total resistance in parallel. Let's move on. Then it says, calculate the current in the 4 ohm resistor in figure 8.1. Lots of mistakes get made with this kind of question. So what they're asking for here is, can you tell me the current in this 4 ohm resistor? Now, what do students tend to do? Well, they get the formula right. They will say I equals V over R. Then what they'll do is they'll say, okay, 4.5 volts. Remember the total voltage at the beginning was 4.5 volts. And then what they'll do is they'll do 4.5 over 4 ohms. Now, why is that wrong? Well, guys, it's wrong because if you're telling me this is 4.5 volts, well, what you're telling me is that's 0. All right, which it's not. They're in series. Students should know that in a series circuit, the voltage adds up to the total. In other words, the voltage here, let's call this V1 and V2. Basically, V1 plus V2 should add up to 4.5 volts. All right. Now, if you knew the voltage in the 4 ohm resistor, and I will leave that for a different day, it's easy enough to find it. But if you knew the voltage in the 4 ohm resistor, then you can do the voltage divided by that resistance to find the current. In fact, I might just bolt it on here. So let me just clear my screen here so we can go down and do this properly. So what we're going to do is, since we know the 4 ohm and the 1 ohm resistor should add up to 4.5 volts, what we're going to do when we do I equals V over R, which most students would guess, well, not even guess, they would have the knowledge. But what we're going to do is understand that when we use this formula, it's not 4.5 over 4, as many students would think. It's 4.5 over 5. Now, why does that work? Because you're supposed to know current in series is the same. So I'll do 4.5 divided by 5, and I get 0.9 amps. Now, I'm kind of tempted to show you how to find the voltage in the 4 ohm resistor, but I do think I'll leave that for another day because I don't want to add confusion. I was thinking about it and I'm just like, no. All right. You will learn a technique where by using some simple arithmetic, we can figure out the voltage in the 4 ohm resistor. And therefore, by doing the voltage across that resistor divided by the resistance, I promise you, you would get the exact same answer of 0.9 amps. But we'll leave that for today. Then part D, calculate the combined EMF of the cells if one of the cells is reversed. Now, again, students will look at this and they'll go, okay, well, what happens if I turn one of these round? So let's pretend I've turned this round the other way. Okay. Well, a student will go, well, surely it's 3 volts. If you've turned one of them around the other way, it's 3 volts. No. What you've got now is you've got one cell, 1.5 volts, basically facing that direction, and you've got 3 volts facing the other way, if you like. Okay, I'm kind of simplifying this. So you've got 3 volts in the original polarity, and you've got 1.5 against. Well, what that actually means is it's 3 minus 1.5, which in actual fact gives us 1.5 volts. Guys, I hope that makes sense. It's my first live stream. I'm now going to go and check it out to see how it looks. But I hope you've found this, useful, beneficial to you. I'll be doing many, many more once I get into the groove and into the hang of this. But what you can expect is exam questions from all various parts of the syllabus. You can expect syllabus topic, specific topics, but in another kind of, PowerPoint background. In any case, before I start rambling, I hope this was useful for you. Thank you very much.